Hello, in this video we want to find the derivatives of the functions which are of this kind: cos fx, cos inverse of fx, sin fx, sin inverse of fx. Now let's look at the equations. So for this one, you see that sin x squared is a function, but still is containing another function. So at this point we shall say let u is equal to x squared, and then from this we shall differentiate u, get du dx, which is the same as 2x. Now after this, what should we do? At this point we shall also differentiate y in terms of u. Now y will be equal to sin x squared is the same as u, and then from there we shall get d1 du is equivalent to what? dy is equal to, if you differentiate sin we get cos, so we shall get cos u. Now then we continue, meaning that we use the formula dy dx. This is the same as if we get dy times dx, and then we substitute du and then du. At this point we have dy du, and also we have du dx. Then we substitute what is our dy du, it is equivalent to cos u. Then what about du dx? It is the same as 2x, and then we shall get our answer as dy dx will be equivalent to 2x then times cos u. But what is our u? Our u, we know it, 2x then cos u, which is the x squared. So this is the derivative of sin x squared. So the next one is cos 4x squared plus 2. We shall also say that y is equal to cos 4x squared plus 2. Then we also bring in a new term. We say u is equal to 4x squared then plus 2. At this point we also do what we did in the previous, that du dx is the same as this one. The derivative of this is equivalent to x. Now also we differentiate y in terms of u, find that our y will be equivalent to cos, instead of 4x squared we write the u, and then if we differentiate this, du dy du will be equivalent to, if we differentiate cos we get minus sin, so we shall get minus sin u. Now we again apply the format that we used in the previous one, that shall use dy dx is the same as dy with respect to u, then times du with respect to x. And now at this point Then by substituting we get dy du is minus sin u, and then du dx is 8x, and then from there we shall get minus 8x, then sin u. But what is our u? But u was equivalent to 4x² then plus 2, and then we shall get dy dx will be the same as minus 8x sin 4x² then plus 2. So this is the solution to the question, which is for part B. Then let us go to the next one. Now this one looks to be like the one we started with, but they are totally different, because this one represents sin x then squared outside the whole of it. So we shall again say that y is equal to sin squared x. Then from this one it has two different ways of solving it. We can use double angle formulas, or we can use chain rule, and then still get the answer. Using our chain rule, we shall see that y is the same as sin x then squared, and then from here chain rule, what does it show us? By chain rule, you know that yn is equal to n times the function, then reduce the power by 1, then times the derivative of the function. And now from here we have y derivative will be equal to our n is 2, then the function is sin x power 2 minus 1, then times the derivative of the function, which is sin. If you differentiate sin, we get what? We get cos x, and the whole of this one will be 2 cos x then sin x. Someone can still continue and say that this one is the same as sin 2x. Now let us still use the other different method of the double angle formula. From double angle formula we can get sin squared from here. Then mean that from here we can get sin squared x is the same as 1 minus cos 2x, then the whole of it divided by 2. Then mean that our y will be equal to, where did this sin? We shall have y is equal to sin squared, shall have 1 minus cos 2x divided by 2. This one can be separated as 1 over 2, then minus 1 over 2 cos 2x. Then we differentiate both sides. Dy dx will be the same as dx of 1 minus 1, then cos 2x. Now this one will be the same as 0, then minus 1 over 2. Then what's the derivative of cos? You know, for constant, this one is a new function. Yes, we shall call it u, and then we'll do what we did in the first step. in the this one. If you differentiate all of it, will be differentiate 2x with respect to x, it will be 2 then times the derivative of the whole of it, the whole of this one, when this one is u, means it is the same as minus sin 2x. Then to that into minus 1 over 2 then times 2 times minus sin 2x. 2 cancels and then we get positive sin 2x, which is still the same as what we got in the previous as 2 cos x then sin x. So that is the solution for that. Let's go to the next. Now for the last part of 2b, we have this, but in the previous video we looked at how to deal with the inverse. So now from here it will be cos will be equivalent to 4x² then plus 2. Actually this one looks somehow fair. If you differentiate both sides, you shall get minus sin y, but we are differentiating with respect to x, so it will be equivalent to 8x. From here what do we get? Our dy dx will be equivalent to minus 8 divided by sin y. Then still in the previous video we dealt with how to get that one, sin y. Shall use from sin squared y plus cos squared y is equal to 1. We can get our sin y is equal to the square root of 1 minus cos squared y. We have cos squared y, so we can just substitute, implying that our dy dx will be equivalent to minus 8 divided by, it's minus 8x, then divided by 1 minus cos squared y under square root, and then the answer will be minus 8x divided by 1 minus 4x² plus 2. All of this is under the square root, and now this will be the solution of the question we have up. So let me just give you some numbers so that you can try them in your convenient time, so that in the next video you can get the answer and see. So in your convenient time, try these questions. Thank you for watching, and take time to share and leave a like. Thank you.